Welcome to another LeetCode problem. So today we are going to solve problem number 2130, maximum twin sum of a linked list. So if you read the problem description, so you are given a linked list of n size where n is even. So you are not going to have any odd linked list. You'll always have n which is an even linked list. Now for the ith node of the linked list is known to be twin of n minus 1 I. So let's say if we have a linked list of even nodes 1 2 3 4 5, so this is even 6, this is even node. So ith node is basically twin of n minus 1 I. So we'll see how what is it and how it is related. And then if you read for the example, so what we have to do is the twin sum is defined as sum of the node and that is a twin node. So we have to take the ith node and then there's a twin node and then we have to calculate the sum, and then from the given list of even length return the maximum twin sum. So let's understand the problem. So let's say for this example, this one, so here you have a linked list of even node. So here total number of nodes are 4. Now if we calculate, let's say I is equals to 0, then ith the twin, what will be this twin node? So that is going to be this one, because n minus 1 minus I, so which will be n is 4, 4 minus 1 minus 0, that is going to be 3. So 0 1 2 3. So this is the twin node, and same for this one, this is the twin node. Now if I take the sum of 5 and 1, that is going to be 5 plus 1 is 6, and then 4 plus 2 is also 6. In case in the here the maximum is always going to be 6, but there could be other cases where the maximum will differ based on the twin node. So let's understand this problem in more detail, and then what is the logic and how we can solve this problem, right? So let's say you have this particular linked list of 6 nodes. So in this example uh, you have n equals to 6. Now let me give you some address. So this is 0th node, this is first node, second node, third node, and fourth node, and fifth node, right? So when I equals to 0, so what is going to be my twin nodes? So that is going to be 1 minus I, n minus 1 minus I, which is going to be 6 minus 1 minus 0, that is 5. So this node, the first node, right, uh, is basically twin of 9. Now same thing if I calculate for uh, I equals to 1, so that's going to be n minus 1 minus I. This is going to be 6 minus 1 minus 1, that is going to be 4. So for this node 3, the twin is coming as 2, the fourth node right here. So same way if I do is for this one, this is going to be the twin node for second node, that is 5, is going to be this one, and for this one is this one, and then for this one is this one. Now once I identify the twin nodes, we need to take the sum, and then from that sum we need to take the maximum and return the result, right? So for first, what is the twin node is 9. For third, what is the twin node is 2, and for fifth, what is the twin node is 4, right? And then let's say if I take a sum of individual twin nodes, so that's going to be, let's say 5 4 9, 3 2 5, 9 1 10. So max is this one, right, 10. So that is your answer, correct? But how do we solve this problem? I mean, understanding is okay, we understand the problem now, but how do we solve this problem? So let's say let me delete all these things. Okay, so if I clear it out, so now we have to think is, okay, once we understand the problem, and then we identify, first of all we identify that twin nodes, right? So if we observe carefully, right, so this is the first half of the linked list and this is the second half of the linked list, right? Now if I go this linked list in the forward direction, and then if I go this linked list in backward direction, and then each node that I get, if I keep summing up, So, and then finally if I try to find what is the maximum, that will give, that will be my result, right? So if somehow if I'm able to uh, cut down the list, now this is my first list then, and then second list will be in the reverse direction, right? 2 4. So this is what I need to add, right? 1 2 9 3 2 4 3 2 1 5 4. This is my second list. If I somehow can obtain these two lists and then I start traversing from here, then that will be easy for me to just start from here and then keep going to next and then keep summing, and then whichever maximum comes in, you take that as a final result. You try to you get the max, right? So but how do we solve this problem? So if you know about how to reverse a linked list, so this is a kind of this is a two type of problem. So where one technique we need is how to reverse a linked list. So there are other LeetCode problems. Maybe you can have a look how to reverse a linked list, and then but we don't have to reverse the entire linked list. We have to reverse from the middle of the linked list. So once I reach to the middle, basically I travel till here. From that particular point, I have to reverse. I don't need to reverse everything. Only these linked lists I have to reverse. So this is going to be my first linked list. This is going to be my second linked list. And then once I get my first and second linked list, I'll just do the normal traverse in the linked list, and then I'll add it, and then I'll try to find the maximum, right? So how do we approach this? So first of all, first step is to find the middle of the linked list, right? From where I need to split it and then I need to reverse it, right? For that, a very simple approach is using two pointer solution, fast and slow pointers. Fast and slow pointers. Let's see how we can do this. So let's say uh, you have this again linked list 1 3 5 4 2 and what was the last one, 9. Okay, now let's see. When I start, I'll have this slow pointer here and then fast pointer as well here. In this case, I'll move slow pointer by one step, so that is going to be slow dot next, but I'll move fast pointer by two steps, fast dot next. So what will happen is fast will move by two step, but slow will only be moved by one step. So in this case, fast will reach to the end, but slow will be at the middle, right? So initially I started here, now slow both are same position, so let's say slow move by one position, so slow is here now, but fast is moving by two positions, so fast will move here because I am jumping by two positions. Again I take another step, slow will move here, fast will again move by two positions. Now again I take one more step, so slow will here, fast is now equal to null. So any condition where I see if fast is null, then I will stop it. Now this is my slow where I reached. So I have already traversed half of the list, rest half is remaining, right? So when I am traveling this, I'll have a condition like fast, either fast is available or fast dot next is available. Until I reach this condition, I'll keep continuing and pushing fast to the end of the list. So now uh, my slow has reached this to this particular location. This is my slow, right? And then fast is gone. So now I don't need fast. I just need to worry about this particular rest of the remaining linked list, because this is the linked list I need to reverse, and my head will be always pointing to here, right? Because I didn't move my head. If I reverse this, and then just I need to traverse both the linked list, uh, and then I need to sum it. So if you don't know how to reverse linked list, I would suggest there is another LeetCode problem you can have a look at, right? So once I reverse this, so I'll get this first linked list is this, which is my initial linked list, right? And then let's say a second linked list I called as a and second linked list or something. Yeah, you can give any name, right? So that will be your my and 9 2 and 4. Okay, this is good, all good. I traversed till the middle and then I reversed it. This is final. Now I just need to sum it. I just need to another loop, a while loop, where I'll keep summing. So I'll sum this one first. So this is going to be 10. Sum this one first. This is going to be 5. And then sum this one first. This one 9. So and then from this maximum is this. So that's the overall logic. So let's have a look at the code. It's pretty straightforward. So first is basically I'll initialize a variable called maximum where I'll be storing the result, and then slow and fast variable, slow and fast pointers. So this particular loop where having fast, because slow I'll be moving by one step, but fast I'll be moving by two steps, right? So in this example that I showed, right, slow moving by one step, but fast moving by two steps. So that is happening here. So and then at the end what will happen, slow fast will cross the entire linked list, but slow will be at the initial this particular portion. Now once I know where is my slow, so I'll assign as a current variable. So this is a generic code for reversing a linked list. When you want to reverse it, this is how you do it. Basically you take current dot next and then you assign to some previous variable, and then you reverse it, you again back it assign to current. And then if you keep doing this, you till your reverse linked list will be part of your previous variable. That is your second linked list. Cool. All I got is I have a starting head and then I have a reverse linked list. Simply just travel the previous linked list, the reverse one that I got here, this one, because this is my previous. This is where previous head is pointing. So if and I just need to travel these three nodes, linked list node. And then out of I'll keep summing up. So wherever I find the maximum, initially max is 0, so previous val plus head val, that will be assigned to maximum, and then I'll move max head pointer to the next and the previous pointer to the next. And then finally once I travel all the three nodes, maximum will be my final result. So that's the overall logic. Hope you understand. Let's run it. Just give a shot. And yes, still running. Yeah, it passes all the test cases. So if I submit it, hopefully it should work. Yeah, pretty much efficient, not too bad. Hope you like the video. Thank you for watching.